All right, so this video will probably end up in 2 parts on YouTube instead. But in any case, so back to where we were. If I were to run this program in a second here, I will. Then it would output whatever the square root of 2.4 is. Pull out your calculators and find out what that is, and you can guess what the match would be. There we go. So GCC demo with -lm to bring in the math library, a.out, and it's 1.054. Right? You did not have to capture that value. What if I didn't? Right? What if I declared double x and double y, and I meant to set it to capture that value into y, but I didn't? GCC, no warnings, even when you turn on, the wall flag, there we go. Y is uninitialized, and I'm trying to print it out. That should hopefully be a red flag to you that you did something wrong there, but it ends up being 0. Why? You can call a function all day if you want to. You don't have to do anything with the return value. Right? So be careful. If you see yourself calling a function without actually putting it into any value, then it's probably doing something wrong. Right? But optionally, you can capture the return value, and usually the most common error I see is, well, you didn't actually do anything with the variable that gets returned, the variable value that gets returned. The convention that we use is lower camel casing for function names, and in general we use verbs, right? Because functions do things, right? Functions do things. Variables that you store them in, number of students or currency or monthly payment, right? Those are things, those are nouns. So we like to use verbs there, and we like to use lower camel casing for function names, right? That is both C and Java. Let's see. Okay, so understand that control flow is handed over to the function, and it computes it until it gets to a return statement. So again, over here in run primes, when I call is prime right here, right? What happens is that normal control flow stops on line 24, jumps down to line 37, and starts executing. When it gets down to a return statement, one of these return statements, I guess there are five of them there, then control is handed back up here to the calling function. And you can do this as many times as you want. You can call, in fact, we're doing this billions of times. We're calling is prime over and over and over. Right? So once you hit that return statement, control is given back to the calling function. Right? As a consequence, any variables declared inside of a function are called local variables. They are locally scoped. Do we have an example here? We don't have an example in this, the one that we did here, but do we have an example in AGM? I guess we didn't do it with AGM. Let's look at the loan. This isn't exactly the one that we did, but it's very similar. So we've got a round to cents and get monthly payment. Right? So let's take a look at get monthly payment here. Right? I've got 3 inputs here: principal, annual rate, and years. 2 of them are doubles, and the third one is an integer. I also have local variables here: monthly rate, which is the annual rate divided by 12. Months, which is years times 12. And I've also got monthly payment, and I'm returning that variable value right there. I've got 3 local variables here: monthly rate, months, and monthly payment, right, to compute the monthly payment. And so consequently, those variables only exist within the scope of this function. This variable is declared on line 56. When we hit that return, that variable is gone and lost. Right? If I declared another variable up here called monthly, in fact I did, there's monthly rate and there's monthly rate. Right? I've got 2 different variables, but they're in completely different scopes. One of them is in the get monthly payment function, one of them is in the main. They are not the same thing. Okay? We'll see a visualization of this in a little bit. So, what about Java? Functions in Java. Again, technically, Java has methods, not functions. Right? But don't worry about that. I'll be going back and forth anyway. In Java, everything is a class or belongs to a class because it's object-oriented programming. Object-oriented programming. A class is their interpretation of an object. And so consequently, functions are inside a class and therefore are methods instead of functions. That's the only difference. For now, we'll restrict our attention to static methods. Public static void main, that static keyword in there, we're going to continue using that. Static simply means that the method belongs to the class, not to instances of the class. We'll understand that later on when we actually do some object-oriented programming and get into classes. But for now, just to understand the consequences of that. To invoke a static method, you use the class name dot function name or method name. Method name, let's go with method name. Right. Like that. And that's why when we use math stuff, math dot square root, math dot sign, or all that kind of stuff, that's because they were all static methods. They belong to the math class, right? And so consequently, you have to call it math dot and then the function name. When we create our own methods, we'll do the same thing. So for example, let's come over here and that's right. I took them all and put them into GitHub for you all. And when I did that, I just moved them instead of copied them. So let's go ahead and go with a new class, and let's just call it my math, right? To distinguish it from the other math class. Now let's go ahead and create a function to round to sense, because that's mathy, right? So public static. What's the return type going to be here? If I want to round to sense. About double, okay. Double. And what is the input going to be? Also a double. And we need to give it a name. X is fine. Right? Right. What else do we need to do before we write that function? Document it. Right? Returns the given value rounded to the nearest hundredth, that is sense. Right. There we go. We're not going to dock you for spelling, otherwise I have to dock myself a lot. Right? And here I'm going to put in the same code that we had in C, return math.round, right? X times 100, divide by 100. There we go. Okay. And I think that if we multiplied this by 100.0 and 100.0, I think that that'll be even better. Right? Now, what's your observation here with respect to the differences between C? Do I have a prototype here? Nope. Instead, what I have is I have just the declaration along with the body. Right? So in Java, there are no prototypes. Right? Java does not have prototypes. Right? You include the documentation, signature, and function body all in one spot. Right? Also, the public key method, or public keyword, excuse me. Public simply means that all pieces of code can see your function and use it. Right? If you didn't have public, then I wouldn't be able to invoke it. And what's the use of a private method? Well, there are use cases for it, but for static private methods, very limited use cases. I mean, you want it to be public, right? Because you want to be able to use it. If I made this, another keyword here would be private. That's basically shutting it out from the outside world. I could use it in my math class, but I can no longer use it anywhere else. Imagine if they had made the round function private. We wouldn't be able to call it. Instead, they made it public, static, and then it's returning a long value here. Okay? Long because it's a bigger integer. Right? In fact, there are a couple of them. Maybe not, but there we go. Let's do one more. AGM, public, static, double, and then arithmetic geometric mean, AGM, of double x and double y. Right. Now we already wrote that code, so what I would do is I would go out, find the code that I wrote, bring it in here, maybe make it a few changes, clean it up or whatever, but I'm not going to do that right now. Instead, I'm just going to leave that as a to-do. To-do, write documentation, right? To-do, implement. Right. Now to get it to compile for now, I'm going to return a dummy value, 0.0, or some flag value or something like that. Or another way that you could do this, come on, what's wrong with you? Oh, return, not double. Return, there we go. Another way that you could do this, I often do this to enforce myself to go back and do it. I throw a new unimplemented exception or something like that. What is it? Unimplemented exception? No, what is it? Unsupported method exception with a message of some sort. You gotta write this. Something like this. Sometimes it's not unsupported method. What is it? Unsupported. Oh, did I misspell it? Unsupported method exception. Unsupported method exception.
Is it no such method exception?
Oh no! There we go. Was that what it said?
Yeah.
No such. Nope. Okay. Yeah. Okay. Let's just go with runtime exception. That's the most generic that you can get. There we go. You got to implement this so that if anybody ever calls this, it gets thrown back in their face. If I call it in my programs because I need to write this, then it gets thrown back in my face with a big red error message that says you got to write this. So that's another way of handling this. This also gets into error handling or exception handling, which is what we'll talk about after we've talked about methods and functions. Right? So there's the basic syntax with respect to Java. Right? Other issues. Right? Oh, here we go. A method or function that doesn't return anything is a void function. Public static void main. Right? Main doesn't return anything. It doesn't have to return anything. And so we use the void keyword. Right? You can also return void. You can also use the return type void to indicate that a function doesn't return anything. Right? Best practice, you still should include an empty, quotation marks there, return statement. That is, return, I'm not going to return anything, so what do? Just put a semicolon there. Right? I'm not going to return anything. Okay? Why would you want a void function? Well, sometimes if you want to like print a menu or something like that, all it's going to do is print out to the standard output, and then it doesn't expect anything to be returned. So there's a void function. Sometimes you want to launch a function and it's going to do something, but it doesn't actually return anything because it does everything inside that function and writes out to disk or writes out to a website or something like that, and you don't expect any return value back. Right? You can create functions with no inputs as well. Right? For example, you can use the keyword, but you shouldn't. Right? So what I mean by that is, let's look at this example: int foo void. Right? Instead, prefer to use int foo with nothing in it. Yes, you can put the void keyword in there in C, but there's some arcane rules that I don't even remember that happen, that there's a difference between these two. But instead, it's just usual to do this. Right? So if you have something that does not take any input and returns some value here that it loads up from a file or something like that, then you don't have to put any inputs in either. Right? Okay. So other observations. One more observation. Recall that functions can only ever return one thing. Right? Otherwise, they're not functions. And again, in some programming languages that seem to allow this, they're not actually allowing it. They are wrapping these things up into one thing, right? It's called a tuple. So if you do have any, how many people do have Python experience from high school now? All right, that's more and more common. I don't know, is it in high schools now, do they still do Java overwhelmingly, or is it more Python now?
I do Java.
Java overwhelmingly, okay. Python, you can do something like, I don't know, I can show you a little bit of Python if you want to. Touch, demo.py, there we go. All right. All right, so here is a function in Python. We call it a function, right? I'll just call it foo. And it takes two inputs, x and y, right? And let's go ahead and return x plus 2 and y plus 2, 3, right? I can return two things. So let's go ahead and create two variables here. A is equal to 10, b is equal to 20. Oops, sorry, no semicolons. I always forget that in Python. A is equal to 10, b is equal to 20, and then c is equal to foo of a comma b. And then let's go ahead and print f. F for formatted. This is how you do print f in Python. And we'll go ahead and do c. There we go. And let's go ahead and go with Python demo. I think I did everything correctly. Oh, no. Oh, darn it. What's it? No. Function, isn't it function foo, or is it just foo? Python function example. Is it just foo? I thought it had to be function. Maybe I'm mixing it. Okay, def, that's it. I forgot. That's PHP right there. Def, foo. There we go. That's why everything was grayed out too. All right. So Python, there we go. 12 and 23, right? Wait a second, it returned two things, right? 10 plus 2 and 20 plus 3, didn't it? Now, what are those parentheses around it? That's a tuple. It took those two things and it wrapped it up into a tuple and gave you that one tuple that consisted of a pair of things, right? So, yeah, you can return two things in Python, but that doesn't work like that. You can actually unroll this too. Let me go ahead and say x comma y. And then we can print x comma y. And you'll see that it'll unpack those two things. Now you don't see the parentheses anymore, right? Because it unpacks those and puts the first one into x and the second one into y for me automatically. Right? Now, in case you think that this is great syntax, sometimes it is, right? But again, remember the XKCD. There are 15 competing standards. Well, I want a universal language here. All right, now you've got 16 competing standards. Right? All right, so those are the miscellaneous stuff. So let's talk a little bit about modularity, and then we'll come back to this next week. Because remember, Friday, it's the home game day, right? So no live stream, no class, and also, unfortunately, no help hours because all the buildings will be shut down. You can still get in with your N card if you need to get into the lab, but none of the LAs will be there holding their regular help hours. Right? All right, so in general, you want to separate your functions and organize them into modules or libraries. Let's come back over here to this example that we were working on with num primes. Right? Imagine that I was writing this larger program. This is only, 50 lines of code or so? Right? But now suppose that I'm writing a much more complex program. 500 lines of code, 50,000 lines of code, 500,000 lines of code. Right? Am I going to be putting that all into one file? Hopefully not, right? Because trying to find something in a file that is 50,000 lines of code, or we call those locks, lines of code, right? That can be very, very difficult. Not only that, but if you're working in a team, does it work for everybody to work on the same file? You're gonna have a whole bunch of conflicts all over the place. Whereas if you'd made it into a modular system where math stuff is over here, financial stuff is over here, input-output stuff is over here, user-based stuff is over here. Now everybody can work on a different module and not step on each other's toes. Right? There are some interdependencies there that still have to occur, but in general, you don't want everything into the same file. You want nice organization. right? You want to only bring in files and libraries when you need them, and therefore those libraries should be small. Libraries or headers in C should be small, right? Modules should be small. In fact, the Unix philosophy is that everything should be small. A program should only do one thing, one small thing, and do it well. For example, listing files, ls, that's a program, right? But it only ever lists files. What if you wanted to sort them? There's another program to do that, sort, right? So for example, let me come over here and let me list all the files. Clear. ls, right? Well, I want to list them in a long format there. All right, there we go. But also I want to sort them. What I could do is pipe that into sort, right? And then you see that, oh, I guess it's already sorted, right? More num primes, there we go. There's all, or I guess I could do less num primes. There we go. There is all of the lines of my program. What if I, for whatever reason, what if I wanted to sort them? I could go ahead and pipe that into sort, and now it's completely sorted. How is it sorted? It's sorted in alphabetical order, right? But of course, it's now scrambled up my program here. See this? All the white space comes first, and then finally the last thing at the last line is I got whatever this is, right? But in any case, that's the Unix philosophy, that everything should be small. Those are terrible examples. I should have, if I wanted to really do that, I should have prepared an example where I've got a whole bunch of lines there. I don't know. We can do it real quick, right? New file, numbers.txt, right? Mash the keyboard. Not a very good mashing. You know what? Here's another tool that you'll probably want to go to someday, random.org. Right? If you want some random numbers, here, lottery quick picks. There we go. Go quick picks. There. It only gave me two. Come on. Now let's get actual numbers here. Integer generator. There we go. And let's go ahead and go. It's 100 integers there. Get the numbers. Yay. And come on, 5 per line. Is that changeable? 1 column. There we go. That's much better. All right, so now let's come back over here to my numbers. There we go. I could say, well, what's the minimum number there? I could sort numbers. Right. .txt. Right, there we go. It's not actually sorting them, is it? Right. What's wrong here? Yeah, it's going off the first value. So, man sort. It's going off of alphabet. Oh, we don't have man pages. Okay, sort help. Merge. Is there a way to treat them as numbers? I could reverse it. Where is that? Where did you see that? N, thank you. N numbers. There we go. So it's probably 1, right? But how many times does 1 appear? 3 times, right? And so I could wrap up these tools, like these small tools, and I could pipe that into another one. Say I could pipe that into awk to print, print it in a different way. I can't think of a good example here, but in any case, you get the idea that you can wrap these tools. Oh, I know who's on the system. Only I'm on the system. Dang it. All right, forget about it. I'll show you cool Unix stuff later on. Right? But anyway, again, it goes back to code reuse, where you eventually want to publish your library so that maybe other people, other programs, right, can use them. Or maybe just you, right? If you find yourself doing these common things over and over again, put it into a personal library so that you don't have to rewrite those all the time. Right? And you can publish it, okay? So I'll do a demonstration next time, where we're going to basically separate prototypes into header files, right? These are files that are called .h files. That seems familiar. .h, where have we seen that kind of pattern before? All of these libraries. They're header files. They contain prototypes. And then we will separate definitions into source files, which are just .c files, exactly the same that we've been doing up to this point, right? And then you compile them together, right? What we do is we go gcc library.c, but we're going to use a new flag now called -c, right? In fact, let's put it right there, -c. What that's going to do, if you remember back on the first day or the second day, I did a demonstration where I said, I'm going to compile this, but I'm not going to produce an executable file. That's the -c flag. It produces machine code, but it does not create an executable program. That's what has happened with all of these libraries over here. At some point, somebody compiled the standard library, somebody compiled the math library for this particular Ubuntu system. Right? And that's what we're going to do. Right? We're going to take these many different functions, separate them out to multiple files, and then compile them together. Right? But we don't have enough time to do that. I don't know, can I show you any cool Unix thing? Maybe. All of our servers are basically, they've been all neutered now. There's the Neuro server. I don't know, let's see who's on right now. So I can find out who, there we go. Chris is over there. Christopher, Chris, and then Burke, B-O-U, right? I get his email all the time. He gets my email all the time because we have the same first name and the same 2 letters as the last name, so everybody goes autocomplete and whatever. I don't know any of these folks. Oh, there's one of your LAs. And then there's Scott. He's one of the sysadmins. And so what I could do is I could go ahead and finger who's on the system, and I could pipe that into sort. Unfortunately, they're sorting by their usernames there. So what you could do is you could pipe this into something called awk, where you only print the second column there. Print. Isn't that right? Awk, print. Maybe that's it. There we go. No, it should only be 2. Dang it. Awk, print, second column. How to get the second, I did it right. Oh no, I didn't do it right. You need a print, this is what it should have been looked like. So there we go. I have to remind myself about this all the time. Oh, come on, it's not working.
So it's just this, yeah,
That shouldn't really matter, but maybe it does on this system. Okay, it does. You host, uname. Okay, it's not telling me what kind of, it's SUSE Linux, I'm sure, because it's Scott that did it. There we go. Now I've got everybody's first name. Let's go ahead and get their last name instead. There we go. And some of these are not going to come out correctly because of that. But now what I can do is I can pipe that into sort, and I've got everybody by their last name. All right. You see what I did? I used one program to find out who's on the system. I used another program to change the formatting, and then I used another program to sort it by piping it into each other. So you can do cool stuff like this if you're at the command line and you start learning these tools. Next semester, you'll probably take CSCE 251, which is Unix programming, a 1-hour course, which will expose you to these kind of tools. But you can write, I mean, you don't have to write a single line of code if you know a lot of these programs. You can piece them together, pipe them together, and do some pretty powerful stuff with just a few lines of Unix commands. So there you go. You can also count the number that there are along with them, whatever. All right. So again, I will see you on Monday because of the game on Friday.